Welcome to our today's lesson. It's about electronegativity, electropositivity, radicals, oxidation states. Yeah, we are going to look at all those aspects. Electronegativity is the tendency of an atom to gain electrons. Electronegativity increases across the period but decreases down the group. The reason for this is because as you move across the period, there is an increase in the nuclear charge and thus a greater attraction for any incoming electron. But as you move down the group, there is an increase in the number of energy levels, and the shielding effect of the electrons make it hard to gain electrons. Electropositivity, on the other hand, is the tendency of an atom to lose electrons. It decreases across the period but increases down the group. The reason for this is because as you move across the period, there is decreasing atomic radius and increasing nuclear charge, and it will be harder to lose electrons. Electropositivity is also called metallic character. As you go down the group, there is an increase in the number of occupied energy levels, increasing the shielding effect, which makes it easy to lose electrons. I hope you've understood that. Let us move on to valency. What is valency? Valency is the combining power of an element. It is usually equal to the number of electrons gained or lost. For example, sodium loses 1 electron to become stable. Hence, its valency is 1. If we go to another element like fluorine, it gains 1 electron to become stable. Therefore, its valency is also equal to 1. Now, group 1 and group 7 elements lose and gain 1 electron, respectively, and hence, they have valency 1. Group 2 and group 6 loses and gains 2 electrons, and hence have a valency of 2. Group 3 and group 5 loses and gains 3 electrons, hence have a valency of 3. Now, when we move on to group 4, it has a valency of 4. Group 8 has a valency of 0 because they have a stable configuration and therefore do not lose or gain electrons. The table below shows some valencies and the atoms to which they belong to. For example, we have valency 1, hydrogen, chlorine, fluorine. Bromine, sodium, potassium, lithium, silver, copper, and nitrogen. In valency 2, we have magnesium, calcium, beryllium, barium, iron, copper, silver, mercury. Then we have lead, zinc, oxygen, and nitrogen. In valency 3, we have aluminium, boron, nitrogen, iron, and nitrogen. Valency 4, we have carbon, silicon, lead, and nitrogen. Yeah, those are just some examples of elements which belong to the various valencies. Oxidation number or oxidation state is the next subtopic we are going to look at. This is the apparent charge of an atom. In neutral state, it has an oxidation number of 0. So this is the apparent charge of an atom, and in the neutral state, that is an atom has an oxidation number of 0. The table below shows some particles and their oxidation numbers. For example, an ion of sodium has an oxidation number of +1. An ion of magnesium has an oxidation number of +2. An ion of aluminium has an oxidation number of +3. Chlorine has an oxidation number of -1. Sulfur has an oxidation number of -2. Bromine has an oxidation number of 0. So what we do is you look at the charge on the atom, and after looking at the charge, then you start with the charge, then the number. If it is, for example, sodium positive, sodium ion is sodium positive, the oxidation number is going to be +1. An element like bromine without a charge, then we say the oxidation number is 0. An element like chlorine with a negative charge, then we say the oxidation number is -1. Let us now move on to radicals. These are groups of atoms that react together as a single unit. A group of atoms that react together as a single unit. They are usually charged. They usually have a charge, and their valency is equivalent to their charge. Some examples of radicals are as shown in this table. For example, radicals with valency 1. We have ammonium ion, chlorate ion, acetate or ethanoate ion, nitrate ion, nitrite ion, hydrogen carbonate ion, hypochlorite ion, hydroxide ion, hydrogen sulfate ion, perchlorate ion. Then those ones with valency 2 include sulfate ion, carbonate ion, sulfite ion, hydrogen phosphate ion, and peroxide ion. Then in valency 3, we have ions such as phosphate ion. So that is an example of a table representing the different types of radicals and their ions. And remember, we said that the valency of the ions is the charge. The charge on the ion represents the valency. For example, for sulfate, the valency of sulfate is 2, and you ignore the sign. When you are giving the valency, you ignore the sign. Carbonate, the valency is 2. Again, ignore the negative sign and just say valency 2. Sulfite is 2. Again, ignore the sign and give it valency 2, and so on and so forth. Now that marks the end of our lesson. We have talked about the valency. We have talked about electronegativity and electropositivity. We have talked about oxidation number. And finally, we have talked about radicals. So that marks the end of our lesson. Hope you've enjoyed the lesson. Thank you and cheers. See you in the next lesson.